So the first two examples that we looked at, we were dealing with a left or a right-hand limit. And we're able to work that out when we have a number divided by zero limit by just checking the signs of the numerator and denominator to see whether it's positive or negative. But when we have a full limit, as we do in this example, and we know that we're dealing with a number divided by zero, because if we plug in 1 to both top and bottom, it evaluates to be negative 1 divided by 0. So we know we're dealing with one of these infinite limits. We just don't know whether the full-blown limit is going to approach an actual thing or not. We have to check. Remember, the left and right have to agree for a full-blown limit. And so here, limit as x approaches 1, we need to test the signs. But we need to test the signs both directions. So taking on values smaller than 1. In other words, the left-hand limit. The left-hand limit. And so we go through and we check. Well, if we take on values a little bit smaller than 1, the numerator is going to be negative. And then the denominator, well, when you put something a little bit smaller than 1 into x minus 1, that's going to be negative. But that's being squared, and so therefore that's still going to remain positive. But when we put something a little bit smaller than 1 into the expression x minus 3, that's also going to be negative as well. And so we get a negative divided by a negative, which becomes positive infinity. So we know that the left-hand limit is positive infinity. We next need to check the right-hand limit. Because we know, because of the number divided by 0, that this is going to be a vertical asymptote. And if you go back to the pictures in the notes, there are really two possibilities. One time, as you approach the vertical asymptote, it's going in different directions on the two sides. And then other times, it could be going in the same direction. And that's what we need to figure out. So, I kind of jumped ahead of myself here. As x is taking on values a little bit bigger than 1, the numerator is still going to be negative, and the denominator is still going to be negative, and we get negative over negative, which is positive infinity. And so it turns out the right-hand limit is also positive infinity. And so since the left and right agree, then the overall limit is positive infinity. Now, if we had a situation where the right was positive infinity, the left was negative infinity, then we'd go back around and say that the limit does not exist. Now, quick little note about limit not existing. None of these limits exist because infinity is not a number. But saying the limit is positive infinity or negative infinity is kind of lending some information about why the limit doesn't exist. And in the case of a full-blown limit here, where the two sides, there's a vertical asymptote, saying that it's positive infinity says it's actually approaching positive infinity on both sides. To say that the limit doesn't exist would be indicating, hey, the left side and right side are approaching different values of infinity. Okay, so just be aware of that, that kind of convention here. So for a full-blown limit here, we have to look at the left and the right side limits, kind of the same as we do with a piecewise function.